Today's kit build is lubricated by Baltic Porter from Nonsuch Brewing in Winnipeg. They describe it as having coffee, chocolate, and toasty malt flavors. Proudly brewed right here in Manitoba. So let's see what's in the box of kits today. And I think I'm just going to grab off the top again. I'm losing some parts already. I got LEDs. I've got a capacitor. There's a switch. Yeah, that should be a fun one. Along with the instructions and the parts I've already got on there, we have an airplane-shaped circuit board. And that's what initially got my attention to this thing when I saw it on the listing. Just that it looks like a fun little kit, one that would be intriguing for somebody who is starting out, somebody young in this hobby maybe. Is the hardest part going to be getting all the parts out of the bag? Really? Fortunately, oh no, it is an IC2 that's got mangled. Oh man, okay. Yeah, I'm going to have to straighten those legs out. So there's some downsides of the cheap kits. They're not packed properly in foam or any kind of packaging that would prevent pins from getting mutilated. Regardless, here is the schematic, and it is a nice simple one. We have a 555 timer set up as an astable multivibrator, aka an oscillator. The timing is set by these two resistors and this capacitor. This is a very standard configuration. I'll put a link down below actually to an article that explains how that works, but it is very, very standard. We have two batteries by the looks of it here in series. So depending on what batteries they are, I guess depends on our voltage. Over here we have a CD4017, which is a decade counter. With each clock pulse that comes in from the oscillator, it advances the count by 1. So on the first pulse, 0 is lit, is set to a binary high, which is essentially the battery voltage, which turns on LED 1. Q2 comes live at the next pulse and lights up that one. Next pulse lights up Q3, and each of the ones behind it goes dark. So it looks like we have 7 LEDs, and then the last 3 outputs are not connected to anything, so we'll have a chase of 7 LEDs, and then 3 pulses of no LEDs, and then it will carry on and on and on. Very straightforward circuit, a very beginner-friendly circuit, and something that probably every beginner in electronics, in non-microcontroller electronics, should do, probably has done, if you're as old as I am. Good place to start in this hobby. But as I said, what's not so good is the way this kit was packaged. So these pins are pretty horribly bent. Anyway, that's the 4017. This little wounded soldier over here is the 555. Straighten these guys up. I'll straighten them a little bit more when we get to the point of actually putting them in, but it just offends me to see them that badly damaged. And then we have some resistors. We have the capacitor. That's the timing capacitor, I think. Or is that... So yeah, there is that electrolytic capacitor. That is the timing capacitor. We also have the little ceramic capacitor, which is connected to... Why are they calling that a volt pin? That's not the volt pin. That's the CV, or control voltage pin. In this application, it doesn't get used. It just gets a capacitor on it for stabilization. Not strictly necessary, but it's a good practice to put it on there. And then there is our 3 resistors. Oddly, there isn't resistors for the LEDs, so I'm assuming that the battery voltage is probably low enough that it doesn't matter, or the internal resistance is going to be high enough that it's not going to blow them up. Now it looks like we've got 3 different colors of LEDs. Those ones look yellow or amber, green, and looks like 3 reds to my colorblind eyes. Correct me if I'm wrong. And other than that, we have the funky looking airplane circuit board. and its fuselage, which I'm going to assume slots on there like that. And do things mount on there? Probably. We'll figure that out. Although that isn't much of a manual, so we have to figure it out the hard way. I think I will disconnect that for now and just solder onto the main board, if I can figure out how to hold it in my fancy board holder here. So let's start with the resistors, and as usual, because I'm colorblind and because these little blue based, I think they're blue, resistors are really hard to tell the colors on, even for people with normal eyes. Let's figure it out this way. That is 10K, which according to that is R1. That's lucky. Not sure whether you can see it from your distance or not, but that is actually labeled for R1. The labels are really, really tiny on these things, so I am not going to blame you guys if you can't see what's going on. Next randomly selected resistor is, looks like 1K, which is R3, which is this one down here for some reason in the reset pull down. Normally you'd pull that right to ground, so I'm not quite sure why they're running it through a 1K, but we'll follow the process. I see an R2 labeled there, and I see an unlabeled resistor position there, and I don't see any other resistor positions, so I'm going to go on a limb, or out on a wing as it were, and say that that is R3. If we just look at the other side, that is connected to pin 15, which according to this is where it's supposed to be. Okay, so let's make that our R3. My process of elimination, this should be R2, but we'll just check it anyway. 5K, 5.1K, close enough. That is our R2, and that's all three of our resistors. So this circuit board is quite a bit different than the ones on the last couple of kits that I did. This has very small pads, and even though they are tinned, well, they're actually taking solder better than I expected, but it's kind of a small target to hit. Still, it's soldering up well, so I am not rescinding my this is a beginner friendly kit yet, although the most unbeginner friendly thing that it has is the lack of manual. So that's resistors, and as I usually do, as I usually say when I'm doing a kit, but I've not said it this time, I tend to start with the physically lowest profile components, the components that are least likely to be damaged by abuse and soldering and just general carelessness on my part, and then finally with the chips and things, although in this case we have sockets, so that's not an issue. Anyway, the two capacitors on the board have nice markings. There is C2, which is going to be the ceramic, so put him in there. And where's my electrolytic? I think it said 10 microfarad. Yeah, 10 microfarads, which is what that is. That's good. It is an electrolytic, which are polarized. There is a negative band on the capacitor, and there's a positive marking on the board. Also, just like LEDs, the long lead is almost always positive. You get caught once in a while when somebody is doing shenanigans with their materials and not paying attention to the factory. Maybe your cheap kit has included really low-end components or factory seconds or something, but almost every time it's going to be like that. Regardless, you trust the marking above anything else. I think I'm going to put the wee power switch in next. It looks like it is a single pole double throw switch, even though it doesn't need to be a double throw. It just needs to go one way, but I guess that was the easiest to get. And that's going to fall out when I flip the board over, so I will blob it on there with a bit of Blue tack. Couldn't find my words for a second. Anyway, there is the one frame mounting pin, and there is the other one. Now it's not going to go anywhere, so I can get that out of there. That was the only purpose for that, is so that the thing didn't fall off when I flip the board over. Look at these 2 electrical pins that we need, and just for good measure, the one that we don't. That way we know the switch isn't going to fall off. Right. What should we do next? How about these Mangolated IC sockets? The sockets are always a good idea, especially for a beginner kit, because it allows you to be a little bit less professional on your soldering and still not damage anything important. This just takes a bit of finesse. It's not too hard to do. Just take your time. Pair of needle nose pliers is always handy. So with the chip sockets, you'll notice that they both have a notch on one end. There it is on the 16-pin chip, and there it is on the 8-pin chip. That indicates that this pin over here is pin 1 on the chip that goes into the socket. And on the board, they have helpfully put the same notch on there, and even on the 555 position, they put a little dot there. Actually, that's got a little dot there too, all indicating that pin 1 is in that corner. Useful information, well, critically important information when you come to put the chip in. And something that I like to do when I'm soldering a multi-legged component is to just get the diagonal corners first, and I can rip that out of the way, and then give it a push with my finger and just remelt that. And remelt that one. I could feel it click to the board. It was hovering just slightly above, but now it is tight to the board, and I can solder down the rest of the pins. And again, I am bouncing around, not just going down one row, and that is entirely to spread the heat out so that I don't do any damage to the plastic of that socket on the other side. If it was soldering directly onto an IC, you wouldn't want to do damage to that with heat. Not strictly necessary, but a good habit, I think, one that I got into years and years ago, and it has prevented me from doing damage to many, many things. How have I done? Those all look perfectly adequate. Next, I think I will put these 2 little battery clips on there. Notice there's 2 pins that go through the board, and then 1 little tab there that prevents you from shoving the battery right through and falling to the other side. And on here we have the 2 pins there and a marking for the little tab. So again, that's nice. This makes up one mechanical connection or one electrical connection to the battery plus the mechanical, and the other electrical connection is already right on the board. So we'll just drop these 2 in place, and it looks like I'm going to need to blue tack them down as well. And blue tack, for the beginners wondering, or people who haven't encountered it before, is just a little kind of putty stuff that is intended originally for hanging up posters and stuff and not causing permanent damage to walls, but it works really well for something like this too. Blue tack is actually a brand name, and this is not the brand name stuff. What I'm using is usually called Fun Tack or something like that, or random other different brand names that you find at dollar stores, and that is where I get mine. You'll find that a lot of the things that aren't, strictly technical that I use comes from a dollar store, because why not? They're cheap, they're local, you're supporting some kid at their first job. Why wouldn't you do that? Right, I guess all that's left to solder down, well, Should I put this piece on now? So on second thought, let's put the LEDs in first. They're marked. There's one on the wingtip there, one on the mid wing, same over there, two on the horizontal stabilizer there, and one that goes up here on the top of the tail fin. And as luck would have it, they all have component designations, so we should be able to tell which one goes where. For instance, LED 1, 4, and 7 are the one that I've got 3 of. Oh man, the colors are in Chinese. But since we've got 3 that are the same color, which I am guessing is red, that will be LEDs 1, 4, and 7. So we'll start there. There's LED 4 on the wingtip, so 1 is on the opposite wingtip. They've got the positive side marked on the board already. For LEDs, the short lead is the negative one, and also there's a little flat spot on the side of the case right there that indicates the negative side. But since the board is asking for a positive indication, it's going to be the long lead. So that one goes there. That one goes up there. And 7 is here. That looks like a negative indication there. And there's a positive there. So it straddles the board. Interesting. I think I'll leave that one to last. So with LEDs and anything that's kind of a display or showpiece, I like to just solder down one leg first. And then get a finger on the other side and physically push it into place while I remelt the solder. That one's down tightly. So is that one. And then I can do the other one, knowing that it's going to stay put and stay where I want it to be. So LED 2 and 3 are green, and 5 and 6 are yellow. Where would we be without modern translator apps? I tells ya, that is really, really cool. When I was starting this out, you know, those things never existed. I don't know what I would have done. Well, I probably wouldn't have been able to get my hands on a kit like this, but that's beside the point. Anyway, I've got the yellow LEDs in my hands. That's 5 and 6, which are the 2 on the tail. Again, long lead is positive, goes that way and that way. And I might as well do the 2 green ones as well, which are LED 2 and 3, which are the ones in the middle of the wing. And the same plan as the first time. A bit of solder on one pin of each of the LEDs. And press them into place and get them remelted and solidly there. You have to hold your finger on it for a second or two just to let the solder cool again. If you don't, you end up with what's called a cold solder joint if they're wiggling while they're cooling. And that one didn't take, so we'll just remelt it and press it into place. Hold, release. There we go. Yeah, they all look like they're well positioned, so get the second lead soldered down. So what do you suppose is the best way to get this on here? Do I want it sticking up or right down tight? Also, I want it that way, because as we can see, that is the positive lead, which is the long one. Yeah, that actually saddles down quite nicely on there. I'll trim those after I've soldered them. That took a lot longer than I wanted it to. Let's see if I can do this one a little bit faster. There we go. And now just gently snip that off. Pays to have good sharp tips on your cutters so you can get in there and not do any more damage. Now I just nicked it, but that was enough to break off like that. Now I guess we just join the 2 boards together, and how that happens is we've got some pads there. So just 2 of them are electrical and the rest of them are just mechanical. and nothing on the back side there. But when we slot these, I guess those would be half laps, probably, together. And then figure out how to fixture this. I'm sure you could do it in other ways if you had other board holding methods, but since I've got this one, I'm just going to use it and put big blobs of solder in there to join up those two pads. That's nice. And then same again on the top side here. Having the iron in contact with both sets of pads to heat them up evenly lets the solder flow surprisingly nicely. Nice little fillets in there. Now it looks like the people that did this part of the board and the people that did this part of the board weren't talking, because the vertical piece has some more pads there and there to solder onto the main board, but the main board doesn't have anything to work with it. And same underneath here. But that is held rigidly together and electrically as well. The only things left to do now are put the chips in and put the batteries on. But before I do that, I'm going to spend a little bit more time straightening these pins out. So remember I was talking about that pin 1 indicating notch there on the socket? As you can see on the chip, there is the same thing. Sometimes there'll be a little dot in the corner where pin 1 is. Not always, but you're almost always going to have that notch. So I'm just going to gently work the pins into their positions in the socket here, making sure that they're not bending in an unusual manner. Straighten that guy out just a little bit more. Okay, and then a push down, and just watch to make sure that I'm not bending them. Looks like they're all seated, so we'll now just repeat the procedure with the 4017 chip. Remember I was saying some pins have the notch and some pins have the dot indicating pin 1? This one happens to have both. So we're doubly sure that that is pin 1. So again, I will put the one row of pins just gently in there and then flex the whole thing over to get the second row in. Take a look, make sure that they're going in straight. Gently squeeze to put them down. Reinspect. I think those are all in good shape. So it showed two batteries in series here, and since these are fairly normal button cells, those are going to be 1.5 volts, so in series for 3 volts. So that's not going to overvolt these LEDs too much. I didn't even need the translator. It is 1220 style battery. Okay. One thing that happens when you're doing this after a while, you tend to accumulate a bunch of different types of batteries. 2025, 377, LR40, 1220. There we go. And it looks like I misspoke, because these are in fact a 3 volt lithium cell, meaning that 2 of them in series is going to be 6 volts, which means I'm not quite sure how we're protecting these LEDs from damage from overvoltage, or more correctly from overcurrent, because there's no resistor in their path unless they're counting on that resistor in the reset circuit to act as a current limiting for that. But I don't know that that is in the path on the 4017. No, it doesn't appear that it is. There's just inverters on the outputs that drive the outputs. So whatever current those little inverters can provide, I guess, is what's going to the resistor, to the LEDs. Looks like you can only source about 3-ish milliamps per output at 9 volt input. Actually 2.5 at typical room temperatures. Okay, well, I guess we'll see if that actually limits the current or if it does any damage. Hopefully not. Well, let's see what happens. Oh, there we go. So it chases across the wings and then blinks the tail and then a pause. Huh. That is kind of cool. I think this would be a fun thing to have on display somewhere. Well, that was a nice, simple little kit, fun to put together. Bit of a challenge due to the lack of instructions, though having the schematic and this helped. It would have helped more if it was in English, but we got there with the help of our little translation app. That was fun, that was relaxing, and that's what these kit builds are supposed to be. Thanks for watching, everybody. Questions and comments down below. I'll put a link to a couple of things that I mentioned, including, if I can find it, a link to where to buy this kit if you're interested in. Yeah, thanks for watching. I'll talk to you later.